Good morning, everybody. Thank you for watching my videos. Please take a look at the rest of my channel if you are interested in electronics, microcontrollers, radio, and other related topics. Today, I am creating a glossary of definitions related to microcontrollers. And that is because I was doing some basic reading and some definitions came up that I'm somewhat familiar with, but I thought I could expand on my knowledge if I created a glossary of relevant terms. So that's too much boring talk already, and I should get right into it. So here I go, starting with microcontrollers. A microcontroller, MCU, is a small computer on a single metal oxide semiconductor integrated circuit chip. In modern terminology, it is similar to, but less sophisticated than, a system on a chip. A SoC may include a microcontroller as one of its components. A microcontroller contains one or more CPUs, processor cores, along with memory and programmable input-output peripherals. Program memory in the form of ferroelectric RAM, NOR flash, or OTP-ROM is also often included on a chip, as well as a small amount of RAM. Microcontrollers are designed for embedded applications, in contrast to the microprocessors used in personal computers or general-purpose applications consisting of various discrete chips. UART, Universal Asynchronous Receiver Transmitter. A universal asynchronous receiver transmitter, UART, is a computer hardware device for asynchronous serial communication in which the data, format, and transmission speeds are configurable. The electric signaling levels and methods are handled by a driver circuit external to the UART. UART is usually an individual or part of an integrated circuit IC used for serial communications over a computer or peripheral device serial port. One or more UART peripherals are commonly integrated in microcontroller chips. A related device, the Universal Synchronous and Asynchronous Receiver Transmitter, USART, also supports synchronous operation. USART, Universal Synchronous and Asynchronous Receiver Transmitter. A universal synchronous and asynchronous receiver transmitter, USART, is a type of serial interface device that can be programmed to communicate asynchronously or synchronously. Purpose and history. The USART's synchronous capabilities were primarily intended to support synchronous protocols like IBM's Synchronous Transmit Receive (STR), Binary Synchronous Communications (BSC), Synchronous Data Link Control (SDLC), and the ISO standard High-Level Data Link Control (HDLC) synchronous link layer protocols, which were used with synchronous voice frequency modems. These protocols were designed to make the best use of bandwidth when modems were analog devices. In those times, the fastest asynchronous voice band modem could achieve at most speeds of 300 bits per second using frequency shift keying (FSK) modulation, while synchronous modems could run at speeds up to 9600 bits per second using phase shift keying (PSK). Synchronous transmission used only slightly over 80% of the bandwidth of the now more familiar asynchronous transmission, since start and stop bits were unnecessary. Interrupt handler. In computer systems programming, an interrupt handler, also known as an interrupt service routine or ISR, is a special block of code associated with a specific interrupt condition. Interrupt handlers are initiated by hardware interrupts, software interrupt instructions or software exceptions, and are used for implementing device drivers or transitions between protected modes of operation, such as system calls. The traditional form of interrupt handler is the hardware interrupt handler. Hardware interrupts arise from electrical conditions or low-level protocols implemented in digital logic, are usually dispatched via a hard-coded table of interrupt vectors asynchronously to the normal execution stream. And it's lost me already. Serial communication. In telecommunications and data transmission, serial communication is the process of sending data one bit at a time sequentially over a communication channel or computer bus. This is in contrast to parallel communication, where several bits are sent as a whole on a link with several parallel channels. Serial communication is used for long-haul communication in most computer networks where the cost of cable and synchronization difficulties make parallel communications impractical. Serial computer buses are becoming more common even at shorter distances as improved signal integrity and transmission speeds in newer serial technologies have begun to outweigh the parallel bus's advantages of simplicity. No need for serializer and deserializer, and to outstrip its disadvantages. The migration from PCI to PCI Express is an example. Basic stamp. The basic stamp is a microcontroller with a small specialized basic interpreter, PBasic, built into ROM. It is made by Parallax Incorporated and has been popular with electronics hobbyists since the early 1990s. Technical specifications. Although the Basic 2 has the form of a 24-pin DIP chip, it is in fact a small printed circuit board PCB that contains the essential elements of a microprocessor system. A microcontroller containing the CPU, a built-in ROM containing the basic interpreter and various peripherals, 2 kilobytes of I2C EEPROM memory, a clock in the form of a ceramic resonator, a voltage regulator, external input or output. The end result is that a hobbyist can connect a 9-volt battery to a basic stamp and have a complete system. A serial connection to a personal computer allows the programmer to download software to the basic stamp, which is stored in the onboard non-volatile memory device. It remains programmed until it is erased or reprogrammed, even when the power of the stamp is removed. If the power is reconnected, the stamp immediately starts executing the program in slot 0 of 8 numbered 0 to 7. Programming. The basic stamp is programmed in a variant of the BASIC language called PBASIC. PBASIC incorporates common microcontroller functions including PWM, serial communications, I2C, and one-wire communications. Communication with common LCD driver circuits, hobby servo pulse trains, pseudo-sine wave frequencies, and the ability to time an RC circuit, which may be used to detect an analog value. Once a program has been written in the stamp editor, an integrated development environment in Windows, the syntax can be checked, tokenized, and sent to the chip through a serial USB mini-B cable where it will run. In-system programming. In-system programming, ISP, also called in-circuit serial programming, ICSP, is the ability of some programmable logic devices, microcontrollers, and other embedded devices to be programmed while installed in a complete system rather than requiring the chip to be reprogrammed prior to installing it into the system. It allows firmware updates to be delivered to on-chip memory of microcontrollers and related processors without requiring specialist programming circuitry on the circuit board, and simplifies design work. There are several mutually incompatible in-system programming protocols for programming microcontroller devices, including PIC microcontrollers, AVRs, and the Parallax Propeller ICSP has been primarily implemented by microchip technology for programming PICs and the DS PIC devices. The primary advantage of this feature is that it allows manufacturers of electronic devices to integrate programming and testing into a single production phase and save money, rather than requiring a separate programming stage prior to assembling the system. This may allow manufacturers to program the chips in their own system's production line instead of buying pre-programmed chips from a manufacturer or distributor, making it feasible to apply code or design changes in the middle of a production run. Microcontrollers are typically soldered directly to a printed circuit board and usually do not have the circuitry or space for a large external programming cable to another computer. Typically, chips supporting ISP have internal circuitry to generate any necessary programming voltage from the system's normal supply voltage, and communicate with the programmer via a serial protocol. Most programmable logic devices use a variant of the JTAG protocol for ISP. In order to facilitate easier integration with automated testing procedures, other devices usually use proprietary protocols or protocols defined by older standards. In systems complex enough to require moderately large glue logic, designers may implement a JTAG controlled programming subsystem for JTAG devices such as flash memory and microcontrollers, allowing the entire programming and test procedure to be accomplished under the control of a single protocol. Firmware. In computing, firmware is a specific class of computer software that provides the low-level control for a device's specific hardware. Firmware can either provide a standardized operating environment for more complex device software, allowing more hardware independence, or for less complex devices, act as the device's complete operating system, perform all control monitoring and data manipulation functions. Typical examples of devices containing firmware are embedded systems, consumer appliances, computers, computer peripherals, and others. Almost all electronic devices beyond the simplest contain some firmware. Firmware is held in non-volatile memory devices such as ROM, EPROM, or EEPROM, including NOR flash memory. Changing the firmware of a device was rarely or never done during its lifetime in the past, but is nowadays a common procedure. Some firmware memory devices are permanently installed and cannot be changed after manufacture. Common reasons for updating firmware include fixing bugs or adding features to the device. This requires ROM, integrated circuits, to be physically replaced, or EPROM, or flash memory, to be reprogrammed through a special procedure. Firmware such as the BIOS is a BIOS of a personal computer, may contain only elementary basic functions of a device and may only provide services to higher level software. Firmware such as the program of an embedded system may be the only program that will run on the system and provide all of its functions. Before the inclusion of integrated circuits, other firmware devices included a discrete semiconductor diode matrix. The Apollo guidance computer had firmware consisting... I'll skip that. ALU, Arithmetic Logic Unit. In computing, an arithmetic logic unit, ALU, is a combinational digital circuit that performs arithmetic and bitwise operations on integer binary numbers. This is in contrast to floating point unit, FPU, which operates on floating point numbers. It is a fundamental building block of many types of computing circuits, including the central processing unit of computers, FPUs, and graphics processing units, GPUs. The inputs to an ALU are the data to be operated on, called operands, and code indicating the operation to be performed. The ALU's output is the result of the performed operation. In many designs, the ALU has status inputs or outputs, or both. which convey information about a previous operation or the current operation, respectively, between the ALU and external status registers. EPROM. An EPROM, rarely EROM, or erasable programmable read-only memory, is a type of programmable read-only memory (PROM) chip that retains its data when its power supply is switched off. Computer memory that can retrieve stored data after a power supply has been turned off and back on is called non-volatile. It is an array of floating gate transistors individually programmed by an electronic device that supplies higher voltages than those normally used in digital circuits. Once programmed, an EPROM can be erased by exposing it to strong ultraviolet light source, such as from a mercury vapor lamp. EPROMs are easily recognizable by the transparent fused quartz window on the top of the package, through which the silicon chip is visible and which permits exposure to ultraviolet light during erasing. Development of the EPROM memory cell started with investigation of faulty integrated circuits where the gate connections of transistors had broken. Stored charge on these isolated gates changed their threshold voltage. Following the invention of the MOSFET, metal oxide semiconductor field effect transistor by Muhammad Attallah, and Dewan Kang of Bell Labs presented in 1960, Frank Wanloss studied MOSFET structures in the early 1960s. In 1963, he noted the movement of charge through oxide onto a gate. While he did not pursue it, the idea would later become the basis for EPROM technology.